Hi, we just released the first video yesterday to accept Kurt's challenge to introduce something that I believe is very useful. And now I would like to explore some options of how we can understand various models, various principles for reasoning, and how we can explore and contrast different views upon the world. I'll briefly recap what was the essence of the message I wanted to convey today. This goes back to what sometimes is known as Potter's box. In a sense, how do we identify principles by which we reason, and applying one of these principles systematically to everyday questions in the world, it generates a worldview. And this is actually where philosophy comes from. Now, these principles are limited to a spectrum, in a sense that there are only so many options you can choose as your assumptions. You're not required to choose any particular ones, but these are among the most fundamental questions you will have to come to terms with if you want to be a clear thinker. To be a clear thinker, you need to be internally and self-referentially consistent in your reasoning. And one thing that you can be assured of is if you are systemic in your approach, meaning this internal consistency, your thinking will be not only more sound, but also more robust. So also in a debate, in an argument, an internally self-consistent reasoning is kind of necessary to have any chance of viability. If you're inconsistent, all the counterparty has to do is kind of push around until your argument breaks down. This in itself is not a safeguard that your argument is right, and thereby we're now going to explore a spectrum of kind of one principle above another. Every principle adds an additional dimension, thereby increasing the space of complexity, and then a larger, more rich space is essentially applied to supervise and govern the subordinated, the principle below it. And each of these principles can manifest in a harmonious form, essentially meaning that they're pure and consistent with the principle of nature, the principle of life. But there are also distorted manifestations possible, meaning like in a sense a misapplication, right? The principle in a sense is neutral. You can, there's like the saying with like a knife can take a life or save a life, right? In the hand of a skilled surgeon, he may be able to save a life by a very skillful application of a tool, but simply having a knife and waving it around is more likely going to lead to damage than good. So the superior mode of cognition and insight needs to supervise the subordinate one to keep it in check and to make sure that it is actually producing results as intended. So the four most fundamental questions, this is just going to be a real quick recap, and then we're going to examine more details. The first question is the cosmological question, like what is your assumption? Why is there something rather than nothing? And you can have different, right? You can say, well, in the beginning there was nothing and that exploded, and now here we are and everything is falling apart. It's kind of like the Big Bang to heat death cosmology. However, this is not the only answer. There's also the possibility that we had a Big Bang and then we expand for a time, that impulse expires and then stalls out, and then through the gravitational attraction we return and converge in a big crunch. But that is not the only option, because when you say, well, if it goes out and then it contracts, that singularity may look very similar to the primordial singularity, which we understand as a Big Bang. So is it then possible that it's cyclic, in a meaning like that it pulsates back and forth? Or is there a certain amount of inversion, right? We have our models, to the extent that we're able to examine and understand it. The inside of a black hole very, very much may look like another Big Bang. So is it possible that when we have an expansion and then end up in a contraction, is there like a kind of like an inversion that happens, that it expands in an like a mirror realm, like in a sense of like that you invert the dimensions into it, and you in a certain sense end up with a inverted image, which of course is fairly similar to the reality we have, right? If you flip all the charges and you flip time symmetry and flip matter into antimatter, then you could maybe you go from a right-handed to a left-handed universe or so, but in large the principles could be very similar. Now, this already touches to some extent to the second fundamental question, which is the teleological question, whether there is some discernible principle, right? Is it just like everything is just decaying and disintegrating and basically we're kind of all heading towards entropy, towards heat death? And the only thing we have as an option is just impose our rule and trying to subordinate reality to our will? Or is there some discernible principle, right? Are there certain forces active that maybe we cannot change on an individual level, but much like with sailing, there is a prevailing wind, and you can use the wind to tack and cut up against the wind, and using the wind to even go in the opposite direction of the force. The first thing that comes to mind is gravity, right? Gravity is a very, in a way, simple organizing principle that through to gravitational attraction, things converge together. And one standard for whether a planet has intelligent life could be whether it only attracts or also is able to deflect asteroids, because that would require a fairly high degree of control to overcome the gravitational attraction and deliberately pinpoint an object and deflect it, which is something that just has been done as with a NASA experiment, for example. The next approach is, well, if we understand the teleology, telos from like a telescope, something that you can unfold, like the principle of unfolding. Can you predict how the whole model is unfolding by understanding the past? Like, can you use the records from the past and reliably predict the future of tomorrow? Now, if you assume that you're existing in a finite box where matter and therefore resolution, complexity does not really change, you could reasonably come up with a belief that, yes, as long as I understand reality and I examine how it worked in the past, I can predict the future. And these are roughly the three dimensions of space that we are all familiar with. However, on this one, I side with Julian Barber that thinking in terms of Euclidean planes and Cartesian coordinates is a big problem in the sense that it corrupts our minds. We tend to over-trivialize nature, like physical nature, simply because we can construct mental models which are simple. We like them and it's easy to adapt them, and most of us learn them somewhere through school, at least I guess by high school or something. You learn trigonometry and let's say like Pythagoras theorem with right angles, and the two smaller sides, the square is equal to the larger sides, and this only holds in a Euclidean plane, which is a special case. If you deal with polar or hyperbolic coordinate systems, then you need to use the generalization of that. There's still a version of that, but you need to generalize it through the inner product. So there are ways how we can kind of dislodge some of these assumptions that we carry forward with some of the math, geometry, and physics as we are taught in school. But the problem is, since these things are introduced at a very early age and just kind of like, well, it's not exactly true, but let's just go with this for now because now we can use some exercises and you can solve some problems with it. It's definitely useful, but usually these assumptions are never examined after the fact. And then whatever belief systems and reasoning system we build on top ends up always carrying forward on one side blind spots and all these over optimizations, over idealizations that sometimes obscure also possibilities of the future, because maybe we operate on a model which is too simple to actually adequately reveal the options that we would have in the physical world. If you go and dislodge from this finite or convergent spaces and you go into divergent spaces, if you think from a sphere, if you go inside, like you reduce the complexity and the degrees of freedom because the space decreases. However, if you go into the opposite direction, the amount of possibility increases because the space increases. Right? If you think of like you have a 1 degree angle, the further you travel out, the wider it gets, and before you know it, a few light years out, it can 1 degree of 360 degree could contain an entire galaxy, which of course is like extremely complex with all the processes and planets and data that go on. Whereas if you go towards the center, at some point you hit the Planck limit, and then you hit a lower event horizon. Right, there's the lower end of the event horizon where we hit the Planck limit at whatever it is, like 10 to the minus 33 centimeters or something like that, beyond which, with all the tools that we have today, not even in principle can probe it. Right, the energy that would be required to probe such a low wavelength, Nima Arkani-Hamed is making this point in his presentations, that if you wanted to go, you hit a limit because you create a small black hole, and if you want to probe lower, you need more energy, and therefore you create a bigger black hole. So the more you try, the bigger the problem becomes. And then, of course, on the upper end, we have the cosmic horizon. Excuse me. Where you end up with a limit of what we call the knowable universe. Now, since Einstein, we know that there's a relationship how we can relate space and time. But Tim Maudlin points out that there's a very key distinction between space and time. It's not just another space of time. He says, because we just took geometry, a 4-dimensional geometry off the shelf that was there, and we applied it to model something which is 4-dimensional, that makes reality look like space and time are on equal footing. But one thing we very easily notice, as he points out, is that in everyday life, time is directed. Everyone agrees which way is the past, but to go from left to right, or to you have rotational symmetry and translation symmetry, and you couldn't say that, in his example, he says like whether America runs from north to south or south to north, because space itself is not directed. I'm inclined to push this a little bit further and go as far and say like, well, the whole coupling it has more to do with limitation in our sensory apparatus. We only have access to one dimension of time, because if you would take a snapshot of the whole world, the best you can discover, the best you can probe, is a certain kind of artifact that encodes that a history has been happening. Julian Barber, in one of his presentations, takes a photograph of Ernst Mach, which is the first supersonic bullet photographed in a gas, and you can derive shock waves. And he says, like, if you give this to a fluid dynamicist and you would tell them what the viscosity of the gases are and the size of the bullet, he can derive the speed of the bullet, even though the bullet has been shot like some 140 years ago or whenever that was. So you have a time capsule where the impulse, the velocity and the dynamics of that historical moment is encoded, is basically frozen. And this is how we reconstruct what I would argue is a triple integral of time. That if you want to have a model for time which is consistent with the 3 dimensions of space that we observe, and you say that time and space is coupled, then it seems weird that time would only be one-dimensional. And what it seems to me is the only thing that we have access to with time is essentially a residue, right? Imagine if you have a body, let's say my body or any physical 3-dimensional object, you can always take an integral and it takes you, like, you reduce it down to one lower dimension. Then you can do it again, from 3 dimensions you go to 2 dimensions, from 2 dimensions you go to 1 dimension, from 1 dimension, right? And in the end, for example, you end up with the volume. But if you reduce my body down to a volume, you have basically something more or less like a sphere. Like you get a radius, which is the mean volume of how I extend, and my position and how I move and how I'm shaped is is completely lost, and also that I have bones and I have certain cavities in my nostrils, in my chest. It's like all these subtle nuances are lost, and I suspect that what we observe with time is much closer to only observing a residue. This is why time is always positive. In like we just say it's in the past, but what we really are able to see is a distance in time, and we call this age. Right? But the age, if you think of, let's say, you're in space and you look at you take two galaxies that are at equal range and you observe the light, that means it has been traveling for the same amount of time and it's meeting you in this very moment. That it basically has the same age because it has been traveling for the same amount, whatever, millions of years. But these galaxies being diametrically opposed, this light was not in causal contact since it has been emitted, right? Because it's different whether light is coming from the same source and basically is able to interact in parallel as it travels towards you, or whether it comes from opposite directions. And so when you apply this, what Einstein really produced, he created a model by which we can understand certain limits. Like if the temporal body, to which we today don't have the necessary tools to have access to it, maybe we're also lacking the adequate models to develop the tools that could probe this sort of this temporal dimensions. So we have a robust system by which we can make time visible, and through general relativity we can see that there's this relationship between time and space. And one thing that to me is very beautiful, I really like the Wick rotation. So the Wick rotation basically says it relates space and time by taking the real axis for space and then the imaginary axis for time. And there's a paper I linked in the session of yesterday by Julian Barber on Platonia, where he talks about something like time and complex numbers. And he talks about the Wheeler-DeWitt equation, like one model for quantum gravity, where both time and the imaginary number I are absent. And he says, well, while the absence of time generally is taken to be a problem, somehow the number I is not really seeming to cause much concern. And this seems, whenever we use polar coordinates, for example, it's much more easy to work with wave equations, like sine waves, and then you can say, okay, well, you have the real, and if you shift by 90 degrees, you end up with the imaginary, and if you shift another 90 degrees, you go to -1, negative I, and so on. So when one place where this occurs, and maybe I should preface this with another presentation of his on I think it's something called On Existence, and where he talks about time, where he makes the point that there's two distinct notions for relativity that you must distinguish, and one is Einsteinian relativity as we're familiar with it and how it's fairly well established. But then there's another one of Machian relativity, which is essentially a relativity of at an instant of time. You know, if you could take a snapshot of the whole universe, or whatever part of the universe you want to look at, imagine you can look at it from the outside. Now from the inside we cannot take such a picture, right? If we take I don't know, Alpha Centauri, we always see it that far in the past, as many light years as it is away from us. But we can reasonably assume that it exists today and that there's some condition there. It's just that through time we cannot probe it, we cannot access it, we cannot derive information from it. But the Machian relativity is essentially a description in space where you have like a foliation that is global, in the sense of you look at the universe from the outside. And I believe such a picture is necessary to to kind of to get around the limitations that a four-dimensional model of Einstein confronts us with. What Bell proved, and what is very well demonstrated, I believe, with Conway's model, where he projects. He has like a little game that he plays with 3 different axes that are perpendicular, and there's always like 2 ones and the 0. He calls it the 101. Also, video I linked in the video yesterday. That a 3-dimensional object with having 3 perpendicular axes is not sufficiently rich, is not sufficiently complex to be able all to encode or to have a definite path encoded towards all the possibilities which you can reach by simply making measurements. Because every time you measure one axis, you have to give up the perpendicular frame. So you always, whenever you make one measurement, you always increase the degree of freedom of the system, because now you have 2 possibilities, and you can create a separation that are entangled, and you can have both those variations, and then you measure another one, and then you create another cross section where you give up the perpendicular plane. And what this suggests to me is that measurements themselves are constructive in a sense of, like, you basically think of it like if you deal with a graph, and whichever component you measure is you lock yourself in to travel along one axis, and then along that axis, either, it can be random whether it's going one way or the other way, but the fact that you constrain yourself from 3 axes down to 1, you always select and therefore refine, advance, and expand the universe. Now, my personal belief is that much of our assumptions, always starting with this Big Bang cosmology and this imagining that the universe was incredibly small in the beginning of time, or what we call the beginning of time, that's just one point of view, and it's very useful for some things, but it may hide additional possibilities. For example, if you would say that as time progresses, the resolution increases. Unfortunately, inflation is already claimed in physics to have this exponential inflation in the beginning of time. But when you think of inflation, not the inflation that we know in physics, but the inflation that we know in economics, right? You just print more and more money, and then the units stay the same, but because you have a larger and larger pool, the pieces seem to, if they are far apart and you increase the number of them, they seem to be further and further apart. As an example would be, if this is simply because of relativity. An example would be, if you can even say 2 towns are 50 miles apart, or if you drive 50 miles per hour, they are 1 hour apart. But now, if you drive half as fast, now they're 2 hours apart. And if you keep driving lower, the places which are further apart seem to recede further from each other. But it's not because they're actually moving anywhere, but this is now assuming the perspective that the points themselves are still, and the resolution of space increases. This would be, as a consequence, this would imply a variable speed of light. And again, I'm not disputing any facts that we can observe with our instruments. This is simply a different model looking at the same data and looking at it from a different point of view that may be able to reveal different things. This was Einstein's original approach. Unzicker has a bunch of videos. I think he calls his channel Real Physics, and I'll try to find something useful to link in the description. Where he says Einstein's original idea, he was working with variable speed of light theories, and he started with the assumption that you have a kind of like a steady state cosmology. He didn't assume that the whole thing was expanding, but rather, if you look at a frame, whether it extends beyond that's a different question, but that the speed of light is changing over time. But the thing is, the way we define time, that we have, like, whatever we take a cesium atom and we measure how many times it oscillates. That's based on how fast the electron spins around it, but that itself is governed by the speed of light. And then we derive second and metric tensor and all that in an entirely self-consistent manner with it. So you cannot use this instrument to probe whether the speed of light is changing, right? The measurements and this circular logic will remain still consistent whether the speed of light changes or doesn't change. I mean, I'm perfectly happy even to entertain the, like when you think about Wick rotation, right? You have like in quantum mechanics, you have h bar, which is h over 2 pi. And whenever 2 pi means one full rotation. So this could pose the question, does this rotation from the real into the imaginary to the inverse to the negative I and back into the real, does this happen every Planck unit of time? Because why not? We just assume that we are standing within time. But what if the universe as a whole is projecting at time backwards, but we're actually moving laterally? That the whole wake, if you will. Alan Watts has a beautiful metaphor where he calls, I think it's the boat analogy, where he says the universe projects out a wake, much like a ship, where the history projects where we have been. But what is important to remember is that the wake is not driving the ship. The ship is free and the ship can navigate, and based on how it navigates, the wake will reflect that in the future. And so this sort of Wick rotation, if you rotate something which has a lower limit, and we have that limit because we have electron volts and we have Planck units, that simply by introducing these atomic mathematical units, and they're not arbitrary, right? They are. We have this from Fourier transform, that you actually, because you have distinct signals like independent components that make up a system. This can be studied in the domain of complexity theory. So, for example, Lenny Susskind has some really amazing lectures on one. He has like a 3-part series. I think it's from Stanford on complexity and gravity. I can highly recommend that. I'm just listing a bunch of things that we can go into the future and examine a particular model of the view of the world. And there he deals with the universe in terms of complexity. Now, this I would like to relate to just kind of like a little bracket. Let's see how much time we have. Okay. Tim Modlin has a video where he talks about the direction of the arrow of time, and he starts with set theory, and he shows certain problems with sets not being directed in the sense of like an open set. It doesn't tell you whether it's open in the sense that you can leave the set somewhere else, or if it's open that things can enter the set but they cannot get out. And this takes us more in the domain of complexity theory from quantum computation and especially quantum error correction. This is another thing that I find quite insightful. Like Donald Hoffman has this in his presentations. He uses the Hamming code that if you would label, like if you want to be able to do error correction, let's say you have axis binary 1 and 0. If you just have 1 and you have a bit flip, you don't know what happened, right? You can basically, data can get lost. If you always code everything twice, then if you have a bit flip, then at least they're not aligned, and you can say, okay, there was an error, but you cannot recover it. Whereas if you have three bits, and whenever one of them is flipped, you can simply assume that whichever one is different, like 001 or 110, whichever one is less, you just round it to the other one, and that can be a very simple and efficient way for error correction. So again, now this is maybe a little bit more speculative, but this is now what I actually came to conclude from examining these things with 3 spatial dimensions, looking at like the mantis shrimp who has more color sensors. The question became very quickly, why do we have 3 components? Because we see, like, we say a spectrum of light, but what we really see is we have 3 distinct channels where we experience relative intensities. And so, to me, it seems quite plausible that the human mind and its bodily form arose primarily to be able to do error correction, to be able to maintain, like if you explore quantum error correction, like you have topological quantum codes and you have various ways to encode dimensions. But one thing, which is, I mean, for something to have a color, you need both a distance and time, right? You have a cycle, which means it's both something that has an expansion in the direction of time, and then the excitation, the amount of curvature of the electromagnetic potential, is also something that you measure in space. So there again, you have this relation between the spatial and the temporal. One place this now integrates the part of Machian relativity where we have spatial frequencies is neutrinos, because neutrinos, they have, if you look at how they're described, I'm also going to try to find a video from Minute Physics. The phase exponent is complex. That means they evolve across space, not space-time, right? Simply across space, they change flavors based on traveling through space. And that I started to ponder on this quite a bit. Again, originally it was just a comment from in one of the recordings from Alan Watts, where he talks about, I think it's a Chinese concept called shape color, pointing out that you can never really have color without it being distributed through a body, through a shape, or a shape independent of a color. And this, together with quantum chromodynamics, like Frank Wilczek has a great audiobook, and of course the accompanying book, where he talks about beauty, and he's the one that got the Nobel Prize for what we now today call calculating backgrounds. And there again, we have at the lowest level on the atomic scale, we have, okay, jump off quickly, where we have color charges very similar to how our eye encodes things. And so is it possible that what we probe there on an atomic scale, when you probe the nucleus and break things apart, that these color charges again reflect in a way the high level cognition that we experience, and that the fact that we see colors is more an artifact of error correction. The same could be said about 3 dimensions, right? We can say, well, we can be in 3 dimensions simply because we can move back and forth and up and down, and one thing which is different from being in 2 dimensions is that you can go in one direction, go in another direction, and come back a different way. Then, right, in a 2-dimensional plane, you always have a contractible path. Wherever you go, you can just expand and then you come back. But in 3 dimensions, let's say you have a hill, you can go through the tunnel, and then you can go around and come back to the beginning of, or you go through the tunnel and you climb over the hill and you come back, right? There's different loops, and you have lines like in what is it called, geology, where they have like the topological maps. You have these lines, these geodes of equal space, and the same we could create in the imaginary realm, meaning like if you have 3 components of time, then you can have creodes as connections, pathways of equal time. And this is why I believe the only thing which is consistent with things like Schrödinger equations and space-time itself, it has to be 6-dimensional, like meaning 3 real dimensions, and perpendicular to that, like perpendicular to each one of them. I can't really show it here. Complemented by 3 imaginary dimensions. Another thing is that I believe since we do have continuity in space, continuity in time, continuity in consciousness, we need to have a description, like for example SO3 with I think it's called double cover SO3, like something that has spin 2 rotation that you have to, right? There's usually the coffee cup example that you have to twist around, and then you keep twisting, and then you twist it again, and then you come back. But you have to have a contractible path. To be able to contract the path without twisting it, you need to have spin 2. And this, of course, the only particle that we know that is spin 2 is as of now is the graviton. So could it be that the graviton is essentially a membrane, a systemic membrane that deals with the boundary, where you have a sphere, and then at the boundary of the sphere, right? If you just think now of the surface, you could flip the whole sphere inside out. So you could have you can have two beach balls, right? You can have one beach ball, and then you can flip the skin, and you could have another beach ball. But you can also have the opposite. You can have the surface of a beach ball where you deal with the whole divergent space around it, and you flip it, and on the other side there's also a divergent space. These are the kind of topics we can examine in complexity theory. Now, the moment you go from a finite system to something that expands beyond it, some of the logics, some of the axioms of logic no longer hold. I usually have the excluded middle, but the excluded middle means that you can eliminate a choice by, like if you have two options, you can eliminate one and then you can be sure that it's the other. But if you have more than two options, standard logic runs into problems. Now, I want to make this very clear that standard logic is very, very useful, and many people misuse this in saying like, oh, well, I don't believe in logic, and so let's get rid of, let's just ignore logic and reason. It's like, that's not what I'm saying. What I'm saying is there is an upper limit at which duality breaks down. There's an upper limit at which we reach the kind of the limits of our mental cognition, of our mental faculties. Even the mind itself becomes non-dual. And this was, for me, was one of the most beautiful moments in Kurt's interview with Donald Hoffman, the initial one he did, where Donald talks about meditation, and he describes, Kurt asks him, what kind of meditation is it? Like, just silence. And then he describes how intense that experience is, because there's something that panics in you, because your whole sense of self, in the sense of like the limited self, like your ego structure, gets confronted with its own dissolution, with its own boundary. And what you find on the other side is, no concept, no word can do justice for it. And this is really my main motivation why I want to give you a framework to systematically explore these things, because in my opinion, I would encourage everyone to explore these possibilities firsthand. Study practices, anything that can support you. There's many tools, there's many devices. You find some of them in tradition with practices with consciousness. Some spiritual traditions can help you a lot. But it's important that you get a firsthand experience, because if you just hear about it and I tell you about certain conditions and certain experiences, you can sit there on an armchair and it's like, yeah, maybe, yeah, well, maybe the guy's convinced, maybe not. But unless you go there yourself and you go see for yourself, you wouldn't have any reason to believe me, right? But once you go there, like for example, what Hoffman describes, this experience is, in a way, it's shattering and it's absolutely incontrovertible. And when you come back from it, there's no doubt that you experienced something that feels more real than the reality we are accustomed to. And it's like similar, like I can go, let's say I have a dream, and then I come back and it's like, oh yeah, it was just a dream, and I can tell somebody on a dream, and that seems kind of like semi-ephemeral, but from within the dream it seems consistent. And only when you go out and come in the waking state, suddenly you realize like, oh, okay, the dream, there were certain problems with the dream, there was some kind of, maybe there's a little bit of like a myopic vision or some kind of logical inconsistencies that were not visible within the dream, because part of the consciousness that simulates your dream also obscures certain limitations or certain defects with it. So, okay, I'm running out of time now. We'll do another session. But all these things have to be examined firsthand in a way where you can know from a personal, individual, and subjective experience. Because only that way can you know affirmatively inside out. And otherwise, it's just theorizing and speculation. There's nothing wrong with speculating about something simply to kind of explore a possibility and see where it goes. But if you really want to understand and get to see that there is a certain, like an infinite sea of consciousness, we haven't even made it to the third question, but the third question will be the ontological question, right? Then suddenly it becomes obvious that on an experiential level, consciousness is primary and everything else is basically an artifact. It's just the consciousness that generates this reality that renders the manifestations within the experiences that we have. I'm not denying it, the material reality of our encounters and our experiences. What I'm saying is this is not fundamental. So I'm very much in line with what Hoffman advocates. And in my opinion, he's sometimes a little bit too gentle and too soft-spoken. And so maybe I'm insisting a little bit more on what I know he knows. And I know for him it's not as, maybe speculation. He says like, look, I don't have any evidence that I can bring back to you and convince you. So the only solution is for you to go there and see for yourself. So yeah, that's my transmission for today. I hope this could open some door. Please let me know if something caught your attention, or I know I rushed through a lot and I just tried to paint a brief picture. And I'm happy to go into details and examine various topics, and I try to list some additional useful information in the commentary. So hope you have a good day.